Hello, everybody. Thank you for joining us for this second hangout of the MOOC Medical Entomology. So I'm here with two trainers, so Vincent Robert, specialist of mosquitoes, and Jérôme de Paquis, which is specialist of sandflies. Hi, guys.
Hi. So I are in Montpellier, France, and Jérôme de Paquis is in his university in Reims, in France.
So let's go to the question directly. So Jérôme, first I have one question on phlebotoms. So can you explain the Leishmania development inside the phlebotoms, please?
Yes, with pleasure. Okay, when the sandfly bite the host, the blood main contains the amastigotes form, which will immediately transform into promastigotes with a flagella, and they will stay in the gut of the sandfly, go out the peritrophic membrane along the gut membrane, and they will grow a lot. There is a multiplication of the promastigotes, and finally, at the end of the insect stage, they will go in the anterior part of the gut, never go through the salivary glands, and will be injected by the sandfly when the sandfly will take a new blood meal. The infective forms at the end of the stage are called the metacyclic promastigotes.
Okay. Thank you.
Jérôme, may I ask a question to you, please? It's concerning the way to speak about sandflies. Some people speak about phlebotomin fly. So what is your counsel, please?
During the last international symposium on sandfly held in Reims, we proposed to change sandfly because the spelling of sandfly is sometimes in two words, sometimes in one word, and because sandfly are not linked to the sand, we proposed to call them phlebotomin fly. But some colleagues said no, it's impossible to change because blah 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 blah. Okay, and finally we never changed from sandfly to phlebotomin fly. But I fully agree with the term of phlebotomin fly, but I will not fight against my colleagues for just a question of words.
Okay.
Because a sandfly for an Australian is finally a biting midget.
Oh, yes.
Okay, so your phlebotomin flies.
So we will continue with phlebotomin sandfly. Okay.
Yeah.
I have another question about the search for the host to feed on blood. So I read the question: what really defines the food preference for the human being and not for animals? And what does this imply in this disease transmission chain?
So this is a question for you, especially for phlebotoms, and that concern trophic preferences, Jérôme.
Okay. Regarding the preference, we don't know exactly why a species is more attracted by a host or by another host. It's a question of chemicals of the host and a question of sensitivity of receptors of the sandfly to chemicals. Okay, but it is known that some sandfly are very host specific, and whereas some other species of sandfly are more opportunistic. And it has a major importance for the epidemiology of the diseases because most of the leishmaniasis are zoonoses. It's really different from malaria, for example, because from malaria, the better vectors are the anthropophilic, strictly anthropophilic ones. But for sandfly, the best vectors are the bridge species between the host, the reservoir, and man. And the best vectors are those biting as well the usual reservoir as well as man.
Okay.
it's completely different from one leishmaniasis to another one. You cannot compare the vectors of Leishmania infantum, for which the dogs are the reservoir of the disease, with those of Leishmania major or Leishmania mexicana, for which rodents are reservoirs. And in some cases, for the classical foci of Leishmaniasis due to Leishmania tropica, where the man is our own reservoir, and the better vectors are the most anthropophilic ones.
Okay, thank you.
Okay, I can add some words concerning mosquito trophic preferences, if you agree.
Of course.
First of all, this is obvious to observe that some species are specialized for human, for bovids, for monkey, for birds, and some other species are not. So this is more or less the same thing than from phlebotoms. Some are specific to host and others are generalists. And there are a lot of cues and signals that are used by mosquitoes. Among the non-specific signals, we can mention the heat, especially for mammals and for birds, of course. But that can be also right for some reptiles if they are in the sunshine. Of course, this is not the case for batrachian, for frogs and animals like that. A second important signal is the CO2, which is very generalistic. And among the very specific signals, we can mention some specific odors, especially coming from the skin or from the breath. This is interesting to note that some anopheline species that are malaria vectors are sometimes very oriented by the skin odors, for instance, Anopheles gambier, and they are biting preferentially around the legs, the feet, and some other anopheline species like Anopheles atroparvus are much more oriented towards the head because they are attracted by breath. And this is very nice to observe some publication. I noted one from Ruth de Jong and Bart Knowles that precise the point beaten in the body of a man. And this is very differentiated between Anopheles gambier and Anopheles atroparvus. One mainly around the feet and the other one mainly around the head. So this is nice to see that. Well, it was just to add something concerning mosquitoes.
Thank you, Vincent. Annabella Fayou join us. So hi, Annabella. Can you hear us?
Hi, Bella.
Where are you, Annabella?
I'm fine.
Okay. So do you want a question?
Me?
Yeah.
Yeah, I have questions to the teachers.
Yeah. Do you want a question? I have a question on Zika virus. So how or from where the Zika virus came and infect the rhesus monkey?
Okay. The Zika virus is an African virus that was first isolated in the Zika forest in Uganda. So it was during a survey for yellow fever in the jungle. They saw that some monkeys were infected with a virus different from yellow fever. So then they have isolated this virus from a rhesus monkey. So it's an African virus. Yeah, it's a flavivirus, Flaviridae family, like dengue, yellow fever.
Okay, thank you.
And could you remember where is coming this monkey?
The monkey from the tree.
Yes, for sure. Thank you for that. I appreciate. But the rhesus monkey is not an African.
The rhesus monkey. It was a monkey, a sentinel monkey. It was used for trying, because they are susceptible to yellow fever then, because you know perhaps that yellow fever it's a virus from Africa, and most of the local monkeys in Africa are not susceptible to the infection. That means that they have no symptoms after the infection. So they use the rhesus monkey as sentinel to see if the yellow fever was circulating in the Zika forest. So then they found this Zika virus, which gives different symptoms, and also the serology was different.
I say that because it's interesting to know that this typically African virus was first isolated from Asiatic monkey.
Yeah.
Another question for you, Annabella, because maybe it's to precise something. One of the MOOC trainees asked about is vector competence different from efficiency? And he the test, because the correct answer for one of the test question was Aedes aegypti is a competent vector to transmit Zika. But in the video, you says that Aedes aegypti and Aedes albopictus are not very efficient to transmit Zika virus.
Yeah, that's mean the same thing. Perhaps that there is. I should have gave some more information. It's competent. This competence means it's related to the vector competence. That means that when you take mosquitoes, you put it in the P3 and giving them some blood with the virus. You can get the virus from the saliva several days after the oral infections. So if you can get the virus in the saliva, that means that the mosquito is genetically competent to transmit the virus you use for the infections. So this is something that you can do in the lab. It's experimental infections. And then when I say that they are efficient to transmit, that means the same thing. That means that you can get also the virus from the saliva at different days after the infection. But the vector competence is not only the transmission. That means that the final step, that means the virus in the saliva, you have also in the vector competence the description of different steps. The first step is the infection of the midgut. This is the infection rate. The second step is the dissemination. That means the virus escaping from the midgut and infecting the internal organs of the mosquito. That this can be described as the dissemination rates. That means the proportion of mosquitoes able to disseminate the virus. And the final step is the transmission rate. That means the number of mosquitoes able to have the virus in the saliva. So the vector competence is these different steps. But usually we use the final step to say that this mosquito is competent. So we can also say that they transmit efficiently. That means approximately the same thing.
Okay, thank you. Another question for Vincent this time. But the vector competence for malaria instead than other virus. So I read the question. So based on the lectures, I get the feeling that there is much more mosquito species that transmit malaria compared with the number of species that are able to transmit arboviruses. Is it true? And if yes, how is it explained?
Thank you, Marie. First of all, I want to underline that I like very much this question. I appreciate it a lot. And I appreciate also the way it is answered. I get the feeling that, so this is very nice for me. And this is interesting to observe that, yes, I must admit that there are much more mosquito species involved in malaria transmission. That number of species of mosquitoes that are able to transmit arbovirus. I hope Annabella will agree with me. And how can we explain that? First of all, my feeling also, not only feeling, but also I verify this is true, that we have a lot of species complex within the Anopheline subfamily. And this is not so right for Aedes and Aedini mosquitoes among the vector of arboviruses. This is absolutely impossible to explain why the ability of Anopheline species are much powerful somewhere to multiply in number of species, and this is not the case for Aedes. So this is just an observation, but this is not really an explanation. I am not able to make that. So, for instance, we have some example. We have the classical example of Aedes aegypti, which is a mosquito species involved in arbovirus transmission all over the world. This is a pan-tropical mosquito species, which is now under any continent except Antarctica. Of course, there is no mosquito there. And by contrast, we have some Anopheline species like Anopheles bombay, which is a species belonging to the Anopheles gambier complex. And this Anopheles bombay is just known from one forest in Central Africa. And this is a good malaria vector, but with a very limited area of distribution. And this question of distribution area are somewhere also important because the maximum area covered by just one species probably is given by Anopheles gambier or Anopheles funestus. They are more or less everywhere in the south of Sahara. But there is no mosquito species belonging to the Anopheles genus dispersed all over the world. Never they are higher than one continent or a subcontinent. Labella, do you want to add something?
Yeah, which is different from the Aedes mosquitoes. So because there are some species, for example, Aegypti albopictus can cover the entire tropical and sometimes more temperate regions. So what I would like to say is that you have different type of cycles. You have perhaps less mosquito species in an urban cycle of arboviruses. That means that only the same mosquito species are involved in the epidemic transmission. For example, Aegypti albopictus are vectors of dengue, chikungunya, Zika, and yellow fever. So this is quite few. They are anthropophilic mosquitoes and living at close proximity with humans. So they are in towns and feeding preferentially on humans. On the other side, you have the selvatic cycles. And then in the selvatic cycles, because this virus at the beginning were from the wild cycle. So there, these viruses are circulating among monkeys or other wild animals, and also zoophilic mosquitoes. And so there are plenty of mosquitoes able to transmit this virus in the jungle. So that's why they are mainly zoophilic, perhaps, but they can transmit these viruses. So I would say that depending on where you are targeting. In the urban cycle, you have mainly two species, Aegypti albopictus, but in the jungle cycle, you have a lot of different mosquitoes. And what is true for Anopheles, as Vincent said, that they are more species complex. That means that for Anopheles gambier, there are plenty of different subspecies and different categories of mosquitoes within the same complex, which is quite different from with the Aedes. The Aedes, we have, for example, Aegypti, but we have a lot of studies working on Aegypti, saying perhaps Aegypti there are several subspecies, but it's less complex than for Anopheles gambier. But this is true. And what I would say also, today you have mainly big outbreaks, pandemic related to arbovirus, because the mosquitoes, which are epidemic transmitters, are in towns. That's why you have a big outbreaks compared to malaria. But malaria kills, and you have is the most important vector-borne disease with 600,000 deaths each year, which is not the case for Zika, for example. So you have, I should say that, okay, arboviruses are are, you know, they are in the front of the stage of today of all the outbreaks, but even if the mosquitoes involved are few. But don't forget the jungle cycle. There are plenty of mosquitoes able to transmit these arboviruses.
Okay, thank you, Annabella. Now I may have a question for Jérôme. It's not a question, but it was interesting because it was a student, a PhD student from Algeria, introduced herself, and she asked she need an explicit key for the identification of sandflies. So I wanted to know maybe what can you do for her, Jérôme?
I can help her, but unfortunately, she writes a few keys available around the world. I can suggest she wait for the flip key tool in the future. But to my knowledge, there is no key dedicated to the countries from Africa north of Sahara. I remember that Jean-Pierre Duday published a paper in the 70s, which could be useful. And she has to be helped with the keys of Abonank. They are all keys, but to my knowledge, there is no modern key to identify the sandfly from Africa north of the Sahara. And she has to go to the original description, but I can help her with very easy.
Probably, Jérôme, you can write something to respond to this precise question in the
I will send you the link to.
Okay, I will do it.
Yeah.
It's more precise to get some references writing them.
And maybe can you explain a bit about Flepkey tool, because this is a key that is in development, would be available next year. So can you tell us a bit, or Vincent?
Why not? Jérôme, you are involved in this project also.
No, but I think you are the PI of this project.
No, in fact, the PI is Bülent Alten from Turkey. Yeah. Yes, also this Flepkey tool is in project. This is in the same way than the classical now MOOC tool, and one and the other key will be devoted to the geographic area around the Mediterranean Sea, and all Europe, all Northern Africa, and all Middle East countries. So it will be available in 1 year probably. And we have about 120 sandfly species, and this will be oriented towards morphology. But we are thinking about adding also some criteria with molecular biology, and perhaps also some criteria of biology only of the sandflies. So this is in project, and we are working on at that time.
Okay, thank you, Vincent. A question for you, or maybe for, I don't know.
Yes, yeah, I want.
So I read, it's about what precautions when studying vectorial competence. The precautions the researchers must take to avoid bites from infected mosquito. If someone can explain or can...
Yes, I'm sure Annabella also can add something on that. So the question is the protection of the experimenter, but this is also the concern of the environment. So we are here within the famous BSL aspect, BSL for biosafety level, and these levels are from 1 to 4. And there are a set of biocontainment precautions to isolate dangerous biological agents. And I can give some example. For instance, at level 1, this is the option to read some non-infected mosquito at larval or adult species. And we have, for instance, here in Montpellier, this kind of facilities. But we have also the so-called vector pole with a level 2 and a level 3. For instance, at level 2, this level is for work involving agents of moderate potential hazard to personal health and the environment. And this is the case, for instance, for malaria parasites like Plasmodium falciparum in culture. At level 3, we have the possibility to infect mosquitoes with Plasmodium falciparum or with a virus like chikungunya or valley fever or something like that. And each time the level of safety increase and the number of constraints also increase. And the qualification of the personnel increase. For instance, in my vector pole here in Montpellier, I am allowed to enter at level 1 and at level 2. At level 2, I received a special training for that, but I am not able to enter at level 3 because this is a restricted area and myself did not receive the proper training for that. And this is very complicated and not comfortable to work in this level of safety. So this is just to explain that we are really faced with this difficulty to be within the rule which is very numerous, and we absolutely must to be right with these rules and safety procedures. Arabella, within the Institut Pasteur in Paris, you have also this kind of constraints, and you have the option.
Yeah, because manipulating some pathogens, you have a big classification of the pathogen depending of the level of infection to humans, and so you have different levels, and the maximum is 4. But we have now the P4 in Institut Pasteur in Paris, but you have the P3. The P3, you have the dengue, chikungunya, Zika, and also the Rift Valley fever virus. But the Rift Valley fever virus is special, is P3+. So this is the rules under the EU regulation and the French regulation. That means that you have to manipulate these pathogens in a special lab with lower pressure inside, allowing avoiding the pathogen to escape if there is something wrong happening inside. And you should be entirely covered with a combination. And with double gloves, you have to put glasses. You have a mask, and everything inside. It's control. You have hoods and a screen where you are every movement you are going to have inside are checked. So before I have the permission to go inside, we have we have to wait for 1 month to get all the training for work. So this is very, very difficult, and you know that for people working on insects can only function at the temperature of 25, 28, which is very hot when you are entirely covered with the combination. So it's tricky to work with insects in the P3, and so that's why there is only a few places in the world where you can do this kind of work.
Okay, thank you, Annabella. Other question about the coverage of nets for Vincent. So I read the question: what is the problem in covering the most of the area of apartments with long-lasting insecticide-impregnated nets, so that people can do most of their daily activities under protection? Is it something about the cost? Or?
Well, this is a surprising question. For me, this is important to note that imprinted bed nets succeed in part because the amount of the dose of insecticide is relatively low. And this is, for instance, the whole quantity of insecticide within a bed net is much lower than indoor residual spraying within the whole part of the house, for instance. So this is interesting to underline that the global dose of insecticide is very low when we are using insecticide-impregnated bed nets. However, I take the point, and we can imagine to increase the protection of people within the house, because obviously we are not always inside the bed nets. We are when we are sleeping, but we are not at daytime, and some protection are sometimes necessary for Aedes biting at daytime, or for Anophelines biting during the beginning of the evening, and malaria transmission can occur at that time. So, sorry, it is interesting to note that some development are in progress concerning curtains impregnated with insecticide, or with the option with the window nets that are or not impregnated with insecticide. We can imagine some metallic window nets that are strong enough to completely forbid the passage of mosquitoes from exterior to interior of the house. So we have mosquito screen in general that can be developed at all entry port of the houses.
Okay, thank you. So thank you for the question. So nobody joined us on the Hangout. Maybe people were shy this morning. I don't know, and I don't see any question on the live. So do you have question?
Perhaps Annabella or Jérôme, you want to add something?
Yeah. But have you announced the course in Laos?
Yes, we had.
You did it.
No,
Okay.
but you can.
Yeah, this is a course in Laos in June of this year, and it is this course is a 2 weeks course that in alternation with the course we have we co-direct Vincent and me in Pasteur Paris. So our last course was in 2018 and next course in 2020, and in the meantime you have a course in the Institut Pasteur International Network, and this year it will be in Institut Pasteur of Laos. So this course is open to around 15 students coming from the region of Southeast Asia and also abroad. And so it's mainly focused on the diseases, vector-borne disease of the region. And Vincent and Jérôme and me, we will be there for giving lectures. And we have another person from the course in Paris. Is Nathalie Boulanger. She will do something on the ticks. So that's occasion to apply. I think that we have until the end of the April to apply for the course. So I think that you can get information on the website or where?
Yeah, and I announce it on the MOOC website and on the platform, so the people have the link, and I could send it again.
Yeah, so do not hesitate to apply.
Okay. Jérôme, do you want to add something?
No question. I have just a question about the rules for colonization of insects without infection. What is allowed and not allowed in France for exotic species? And do we have to register somewhere? We don't have colony yet in Reims, but we are only in BSL1. We have a BSL2, but I don't know finally, because I would like to start the colonization of Malagasy species, but I don't know if it's really allowed.
There is no specific rule for that. We are not obliged to have something special because there is no infection.
Yes.
But if it is exotic mosquitoes, for example, dengue mosquitoes from Asia to Reims, I think that you should ask for the permission to your university. But otherwise, it's mosquitoes from your garden or outside your lab. I think that there is no problem for that.
No, it's by luck.
Yeah.
Okay.
Okay. Thank you so much for answering the question of the MOOC trainees. So I think we can close the Hangout.
And our next one will be in 2 weeks.
The Friday, next Friday, April 19th. So next week, next Friday at 10 a.m. with you and Nathalie Boulanger.
Okay.
With you, including me?
No, Jérôme,
Oh,
you can
okay.
join us if you want, but if you
No,
don't
if you
want,
have question, I will be free.
yeah.
Ask me if you need it.
Okay, thank you very much.
Okay,
You're
thank
welcome.
you.
Thank you
Bye-bye.
very much, and
Bye-bye.
see you. Bye. Bye.